3, matrices and systems of equations. So the first thing we're going to do is matrices and row equivalent operations. So they might give you a system of equations, or you might have to write a systems of equations that looks like this guy. And then I have x plus 4y equals -2. What I'm going to do is I'm going to write a couple different matrices for this. So a matrix is the singular one. A matrices, or matrices are plural. So a matrix is singular, and this guy's plural. So I can make an augmented matrix. So an augmented matrix is basically going to have all those coefficients and the answers. So you need to make sure that the x's are on top of each other in a column, the y's are in a column, and then you have the equal signs. And when I make that augmented matrix, I will have just the coefficients of the x's, the coefficients of the y's. Make sure you pay attention to the negatives and positives. And then I'm going to make a little dashed line over here, which is going to represent the equal sign. So you have to have everything equal. Like you have to have x, y equals, and then the numbers. Then I have 7 and -2. Also from this same systems of equations, I could make what's called the coefficient matrix. And that will just be a square matrix. And it will look like 2, -3, 1, 4. And I always say them like you go across and then start at the next row and go across. And that's because when we type them in the calculator, when we get to that point, that's kind of just how the calculator does it. It'll, like, when you hit enter, it'll go like here, then you press enter and it'll go here, and then here and here. Okay, you will be asked to find the order of the matrix. Order is going to be the rows by the columns. Think columns as like Greek columns. They stand up and they support little things. So this is my picture of a column. Okay, so columns go up and down. Okay, so your columns go up and down. So then your rows are the other direction. So here, there's 2 rows and there's 3 columns. Okay, that the square ones are really nice. This one is just a 2 by 2. And that's the, just for notation, make sure you use square brackets. That's a square. So square brackets represent that it's a matrix. The dashed line, sometimes you'll see a solid line down it. That one really doesn't matter. Just represents that that's where the equal sign would go. I can write a matrix for any systems of equations that I'm given. For example, if I have the following equations, I have 2x minus y plus 4z equals -3. And then I have x minus 2y minus 10z equals -6. And then I have 3x plus 4z. But I want to make sure that I keep those z's on top of each other. And that equals 7. So then when I write my matrix, I am just going to write the coefficients. So I have 2, -1. So make sure you pay attention to those signs. 4, then I make my little dashed or my solid line. -3, 1, -2, -10, -6, 3, 0, 4, 7. So the book is pretty good about making sure it leaves a space here. Just it has a big space. And make sure you realize that that represents a 0y when we write it into matrix form. And then we're going to use what we call row equivalent operations. And we are going to use those to get it into what we call Gaussian form. Not necessarily Gaussian form, but Gaussian elimination is what we're going to use. And Gauss was a really famous mathematician. So we have Gaussian elimination to do that. And basically, we have a couple rules that we can use to do whatever we want to with the matrices. My first rule is that I can interchange any two rows. So I can interchange any two rows. My second rule is that I can multiply each entry by the same non-zero constant. So I have multiply each entry and each entry, each one of these numbers is an entry. So I can multiply each entry in a row by the same non-zero constant. If I multiplied it by 0, that wouldn't work out and nothing would be happy for me. By same non-zero constant. And my third rule is I can add a non-zero multiple of one row to another. So basically I can add those rows together. Add a non-zero multiple of one row to another. And basically all that means is that I can multiply these guys and then I can add them together. And then I can switch where they live because it doesn't matter which one comes first. My goal when I do that is to get basically this diagonal here, the very bad diagonal. So let me try to redraw a diagonal. There's my undo button, and then I'm going to pick a line. So I'm going to go along this diagonal, and I want these all to equal 1. That's what I want. And everything underneath this diagonal, wherever that diagonal is, I want those to all be zeros. Okay, I probably would have been better off to write it over here. 0, 0, 0, dash, dash, dash. I don't care what happens over here. Okay, but I need 1, 1, 1, and some zeros. So I'm going to rewrite this on the next page. You guys don't necessarily need to. Okay, so really what I want to do is try to look for ones, because ones are going to make me happier than anything else. Okay, so this one has a 1 in this space. So basically what I want to do is flip-flop them. So I'm going to write off to the side that my new R1 is equal to my R2, and my new R2 is equal to my old R1. So my row 1, let me try to make it up a little higher. My first row is now going to be 1, -2, -10, -6. My new second row is 2, -1, 4, 3. I didn't do anything to my third row at all. So you could write R3 equals R3, you don't need to. Okay, and then I basically want to get these two things underneath here equal to 0. Since I already have the 1 in the first place, I need them equal to 0 now. So what I'm going to do is my new R2 is going to be equal to -2 times row 1 plus row 2. That's going to give us that 0. So the first row doesn't change, so you could write R1 equals R1. I'm just going to copy the first row down. Okay, so what I'm going to do is I'm going to take -2 times the first one. So that's -2 times 1. So if I just want to think about it as I'm doing everything to this row right here. So I have -2 times 1 is -2 plus 2, that gives me 0. I have -2 because of this guy times -2, that's +4 plus -1. So I have +4 and -1 is +3. So then I have -2 times -10 is going to be positive 20, and a 4 will be 24. And then I have negative 2 times negative 6 is positive 12 plus 3. That's because I didn't copy down this guy right, so that should be negative 3, and then that will give me a positive 9 right here. So first lesson is make sure you have everything written down correctly. Then I'm going to make my new row 3, and that will be, since it's a positive 3, I need it to be negative, so negative 3 times R1 plus R3. Oops, that's an R. And so if I go back and look at my other page, so I have these 3 rules that I can do, and basically I'm taking on every time I write a new row, so when I say like R3 equals, I'm doing all 3 of these at the same time, which is fine. We could do it each step by step, but so I'm multiplying one row by a number, and then I'm adding it to another one. Okay, so then I have negative 3 times R1. So I have 1 times negative 3 plus R3. That equals 0. Then I had negative 3 times negative 2. That will give me positive 6 plus 0. And then I have negative 10 times negative 3. That's positive 30 plus 4. 34. And then I have negative 6 times negative 3. That's 18 plus 7. So 18 plus 7 is 25. Okay, and then my next step is that I want to get this number equal to 1 because I want 1s in the diagonal. So what I'm going to do is multiply everything on this row by 1/3. So my old row 1 doesn't change. And then my new row 2 equals 1/3 of my old row 2. So I have 0, 1, 24 divided by 3 is 8, and 9 divided by 3 is 3. I'm not changing anything on my bottom row yet. Now that I have a 1 here, I can go ahead and change this bottom row. So what's going to happen is my first 2 rows are actually going to stay the same, so I just rewrite them. This is going to take up a lot of paper. So I have 0, 1, 8, 3. And then I have to multiply this bottom row. I have a 1 and a 6. So my new row 3 will be negative 6, so I need the opposite signs, times row 2. And I'm adding that back to row 3. Okay, so I have negative 6 times 0. So I take negative 6, so this is really hard to see, sorry about that. I have negative 6 times 0 plus 0, because this was my old one. So I still have 0. And then I have negative 6 times 1, which is negative 6 plus 6, is 0. Then I have negative 6 times 8, negative 48 plus 34 gives me negative 14. Then I have negative 6 times 3 gives me negative 18 plus 25, and that gives me 7. I think sometimes the hardest part is actually figuring out what it is that you want to do. If you wanted to rewrite them out as one step, like each step separately, you could do that. Sometimes I think it's just easier to write out one big thing. Okay, but what I still need to have happen is I need this guy to be equal to a 1. So then over here, you guys would probably work just straight down. I copy down my first rows 1 and 2. I have a 1, a negative 2, negative 10, negative 6, 0, 1, 8, 3. To get that equal to a 1, I have to divide it by 14. So my new R3 is equal to 1/14 of my old R3. That's going to be 0, 0. Oh, and it needs to be negative as well to get rid of the negativeness. And that will be +1, and they have to be +1. That's why I had to put in that negative sign that just looks like a triple equal bar. And then I have 7 divided by or times -1/14. 7/14 will be 1/2, and that will give me -1/2. So what this tells me, back if I look at my systems of equations and I look at my variables, I had an x, a y, and the z. I can write new equations from this. I can write x plus or minus 2y minus 10 equals -6. Anywhere I can go back and forth into equal signs and to equations, I can have y plus 8 equals 3. Then I also have z, or I'm forgetting my z's here, sorry about that. And then I have z equals -1/2. Now this is the actual useful equation. I can plug this right back into right here. Then I will have y plus 8 times -1/2 equals 3. 8 times -1/2 is a -4. So I can add 4 to both sides. And y equals 7. Now I can go through and plug both of these back into my top equation. And I have x minus 2y is 7 minus 10 times -1/2 equals -6. And that will give me x minus 14 plus 5 equals -6. Okay, 14 and 5 with the -14 is -9. So when I add 9 to both sides, I get x equals 3. So that's how this is really nice actually, and it's really actually a useful tool. Some of it is really confusing, but we'll do some of these and you'll get really good at them, and then we'll learn to use the calculator to do it for us, which actually will make it easier, but you need to understand what's going on, what the calculator is actually trying to do. Your book actually calls this row equivalent form, I think is what it called it. And then the next thing that we have is called reduced echelon form or reduced row echelon form. So everything that we just did on this back page is called row echelon form, which kind of seems weird. It's named after a big math guy too. Maybe not actually, because it's not capitalized. And then we're going to do what we call reduced row echelon form. So if I just take my old stuff that I had over here, I'm just going to copy this over to my next page. So just go ahead and rewrite this equation right here, or the matrices, I mean. Okay, so then I have the same matrix, and the one that I had here was just the row echelon form. It wasn't a reduced one. So what reduced means is that I'm going to go through the same steps, and I also want to get these 3 pieces, these extra pieces equal to 0. So what I'm going to do, so still the first way to do it is get these bottom ones equal to 0. So everything I have to do, I have to get it into that just plain old row echelon form. And then I'm going to keep reducing it. Okay, so what I'm going to do is I'm going to use this equation to get rid of this one first of all. Okay, so when I first do that, my R1, my first row, will be replaced. I need to get this 1 right here to multiply to a -2 or to a +2. So my new R1 will be equal to 2 times R2 plus R1. I probably can just erase this line since I don't really have anything written there. Okay, since they're already opposite signs, it's not a negative at all. Okay, everything else is going to stay the same. So what I'm going to go ahead and do is just write down this second row. Okay, and then I'm just rewriting my third row. And then I'm going to do the operations that I said I was going to do. So I'm going to take 2 times my second row. So 2 times 0 plus R1 is 1. Then I have 2 times 1 is going to be 2. 2 and negative 2 is 0. Then I have 2 times 8 is going to be 16 minus 10. 16 minus 10 is 6. And then I have to do my third row, so I have 2 times 3. 2 times 3 is 6, plus 3 is 9. Okay, now I have to get rid of the 6 and the 8 here. And so the first thing I'm going to do for that guy is I'm going to have a new row 1 and a new row 2. Okay, and then in order to get rid of the 6, I'd have to multiply. So my new R1 will be, so to get to get 6 to go away, I will have to multiply the third row by negative 6 and add that back to my old R1. Okay, and then in order to get rid of the 8, I have my new R2 will equal negative 8 times R3 plus R2. Okay, since my R3 isn't changing, I like to just go ahead and rewrite it. And that makes it a little bit easier to keep track of things. Okay, so pretty well, if you guys have noticed, your 1s and your 0s are going to stay 1s and 0s, but we'll go through it just to do the steps. So I will take negative 6 times 0 and add that back to 1. That gives me 1. Then I will take negative 6 times 0 and add that back to 0. That gives me 0. Then I will take negative 6 times 1 and add that back. That will give me 0. And then the one that's actually going to matter over here at the end, so I take negative 6 times negative 1/2. That will give me positive 3. Positive 3 times 9 gives me 12. Okay, then I'm going to do the same thing. Except I'm going to do it with negative 8. Negative 8 times 0 plus 0 gives me 0. Negative 8 times 0 plus 1 gives me 1. Negative 8 times 1 gives me negative 8 plus 8 is 0. Then I have negative 8 times negative 1/2 gives me negative 4, positive 4, plus 3. That gives me 7. Okay, so this one worked out nice because I've already done this one. So if I go back and I look at that, I should be able to check my answers. I should have 1/2, negative 1/2, a 7, and a 3. However, I don't have a 3 right here, so I know I've done something wrong. So you guys can always check yourselves without using matrices. It makes it a little easier. So I'm going to go back and I'm going to check this first step that I did right here. So I have R1 should be 2 times R2. So I should have 2 times R2. That should be 6 and a negative 6. I have no idea what I was thinking because I should have got a 0 right here. And then when I did that down here, I should have done negative 6 times R3. So negative 6 times 1/2 gives me negative 3 or positive 3. I've done that every time. Positive 3. So make sure you guys keep track of your signs because I am obviously not very good at that. And then I have positive 3 plus 0. Because of this, the R1 plus 0 gives me 3. So then I've gone back, I've checked my answers. So you guys should be able to kind of realize where you've gone wrong at. So that's how we get it into reduced row echelon form, and I always call it row reduced echelon form. So just remember that that's what I do. And I do want you guys to be able to check yourselves in the calculator, so I'll show you how to do that real fast. So in order to type this in the calculator, you have to know what your order is. And remember, your order was rows by columns. So what I'm going to do first of all is I'm going to hit my second button. And on top of this X inverse key, there's a word that says matrix on it. I'm going to go over to edit. And I'm just going to hit enter when it's highlighted on A or whatever matrix you want to edit. My order of this one is a 3 by 4. I type that in first, and it'll automatically populate everything with zeros whenever I push enter. And then I'm going to go ahead and I'm going to go back to my original equation. So I'm going to go way back to my very original one, which is this guy. So it's actually kind of hard to see. Then I pick my calculator again, and then I'm going to go ahead and I'm going to type these in. So I have 2, when I hit enter, -1, enter, 4, enter, -3, enter. As soon as I hit that one, it automatically brings me back down to the next row, and I have 1, enter, -2, enter, -10, enter, -6, enter. Whenever I get done with that last entry in that row, it brings me back down. Then I have 3, 0, 4, 7. Okay, and then I'm going to quit out of that menu. Okay, so I quit out of here and I go back to my home screen. And then I want my row reduced echelon form. Reduced row echelon form. I am never going to say it in the right order, and I've accepted that. So you guys should accept it. And the reason I don't do it is because we call it RREF in the calculator. Row reduced, reduced row, it's the same difference because it's RR. I want RREF, so I just went up into my menus. So I'm going to hit enter. When I hit enter, it brings it back to my home screen, but I have to specify what matrix I want it to find. If I had something in B or C, I could pick those just as easily. I'm going to hit enter on A. You could close it with the parentheses, you don't have to. And then I'm going to do that. And it gives me 1, 3. So this is exactly what I have over on this next page. And what this actually tells me is that x plus 0y plus 0z equals 3, which really just means that x equals 3. I don't have to write out this whole equation. That's precisely why I'm not doing this. I have y equals 7 and z equals -1/2. I want you guys to be able to check yourself in the calculator, but you need to still be able to do it out by hand. What you can also do to make sure that you got this first one right too, so this one over here that we did first to get it into just our plain old row echelon form, I can just do second matrix, go over to my math menu on the matrix menu, and then I can pick REF, which is row echelon form. So ref, I pick ref, and then I do matrix A. Whoops, it didn't pick matrix. So I'm going to delete those guys and delete it one more time maybe. And I do second matrix A, enter. It's a little bit delayed on here. I have not quite everything the same, but since it came out the same either way, it's okay because there's a couple different echelon forms that we can get. So in this echelon form that it did, it had a 1 in both of or a 0 in both of these places. But you can also scroll left and right on these as well. And so this got a couple different numbers. The one thing that we do have in common is that bottom row equals a -1/2. So make sure you at least have that bottom row equal to the same thing, and that'll tell you a lot. And then what we're actually going to do, there's a couple weird things that happen with matrices. And so we're going to talk about those weird things that happen really fast. If I get, whoops, in my calculator or by hand, if I have a row of zeros, And it would absolutely not matter what I had up above. If I had a row of zeros, it would represent two lines that are on top of each other. So basically the same line. And so I would have infinite solutions. And my pen is not working very well. My computer is actually really slow. I would have infinite solutions. Now then, if I have basically a row of zeros and a number, so this guy is not 0, it means I have no solution. And if you're checking these in your calculator, it's always going to be the bottom row. It would not necessarily be the bottom row when you guys do it out by hand. The calculator just kind of automatically does it to the bottom row. Again, it doesn't matter what I have up here. I could have absolutely anything up here. Okay, but if I have some number over here, it's no solution. If it's a complete row of zeros, it is infinite solutions. And if I do have something that's infinite solutions, what I'm going to do is I'm going to write out these equations. So remember how we could write this out as x minus 2y minus 10z equals negative 6. What I'm going to do is I'm going to still solve for an ordered triple. I'm going to solve for my xyz triple, no longer a pair, and I still have a habit of calling it a pair. I'll try to remember to call it a triple. What I'm actually going to do is solve each thing for x or y respectively. So this one I don't necessarily have to because it does have a one number solution or one triple solution. And then I'm going to add 10z. And what I'm going to get is x equals, my computer is being really, really slow, x equals 2y plus 10z minus 6. And I'm going to go ahead and just write that in for whatever I have up here instead of an actual number. In this case, that's not what I would be doing. I would just write out 3, 7, negative 1/2. And remember to just write them x, y, z. Okay, I want you guys to do homework on pages 510. I want you to do numbers 1 through 14. It should be mostly just writing things out. You're not having to actually solve anything here. And then I want you to do 15 through 39 odds. And it is all stuff that you can do by hand. You know how to solve them no matter what you do, but I want you to also do them with matrices. And that's going to be the hardest part. You can check it with your calculator. You can check it by doing it by hand where you know how to do it some other way. But I want you to get some practice doing these ones.